I'll show some pictures here of the different parts I made for this kit while I give you a little background about this specific diff drop. I assume you know what it's for, but for those who don't, the primary goal of a diff drop is to reduce the CV angle at max rebound, or more commonly referred to as max droop. Any spacer lift or extended travel coilover will lower the rebound position of the wheel with respect to the differential and thus increase the CV angle. I went with icon coilovers mainly to maximize my wheel travel, which is why I'm making this diff drop to help protect my CVs. The strength of a CV joint is proportional to the operating angle. So even if a lift keeps the CV angle within an operational range with no binding, it still could have serious consequences for the strength. So if you want to improve CV strength, diff drops sound great, but there are two trade-offs that must be considered. The more minor of the two is ground clearance. A well-designed IFS system will try to maximize ground clearance between the wheels, and that's generally limited by the differential. As you'll see in this video, I had to remove part of my skid plate to allow the differential to drop a bit lower, and that means I lost a small amount of ground clearance right below the differential. The other trade-off, more important in my opinion, is plunge. If you're familiar at all with geometry, you can visualize the front suspension as a 2D model of a 4-bar linkage. That's the frame, knuckle, upper and lower control arms. If you add another part, whether that's the tie rod or the CV, the positioning is critical so that it can move freely in parallel to the suspension. Moving the differential downward misaligns the motion of the CV through the suspension travel, which means it will now plunge in and out more than is intended. There is an allowable amount of plunge for the CV, which again is tied to the angle. For example, when the CV is straight, it can plunge the most. In this case, about 20 millimeters in and out. When the CV is maxed out at about 30 degrees, the plunge is reduced to about only 10 millimeters in and out. I chose 20 millimeters drop for my differential drop because that's just about maximized the CV plunge I have available. If I were to drop a bit further, 25 mils or 30, even though the CV is at a lower angle, the plunge has exceeded the design limits, and something in the system is going to be stressed excessively. Here you can see the max CV angles in jounce and rebound for both stock and icon equipped suspension, and for the standard differential position versus the 20 millimeter drop. Just putting the icon suspension on increased my max CV angle at full rebound by 50%. The 20 millimeter drop reduces the max angle by over 3 degrees or almost 12%. Still not as good as stock, but a significant improvement versus where the icons put me in the stock position. So these started off obviously as a flat 1/4 inch steel. The reason I went with 1/4 inch is the original part is I think the stock diff drop is 5 mils thick. It might be variable in different, whether it's the drop bracket versus the mounting plate, but I didn't want to go any thinner, especially since it's going to protrude a little lower. And going with 1/8 inch would have been a little thinner, so I just went up to the next step to 1/4 inch. But 1/4 inch is no joke for bending. Basically, I had to drill holes. I did this with the Tormac so that they were exactly in the right position. So that obviously made it easier to bend, but also kind of served as a guide for lining things up. When I bought a brake, probably cost me I think almost $300 on Amazon. If you're looking for the most cost-effective solution for a diff drop, that's not the way. Probably keep calling, who is it, Rough Country. I tried a couple times, they weren't willing to sell it, and I figured I could do a better job anyway. But as far as spending $300 on a brake, we have a 10,000 pound press on the farm, and I figured, you know what, having a proper brake for bending sheet metal, especially heavy sheet metal, would be extremely useful. So this was kind of an excuse to get it. I'm sure I'll use it in the future, but long story short, 1/4 inch, it's really hard to bend. And also you kind of got one shot at it. As you can see here, this fractured when, it was the first part I bent very easy. And then I realized when I went to bend these other flanges, this bend was in the way of how it needed to position. So keep that in mind when you have multiple bends on a piece, you kind of got to bend them in order. And this had to go last. So when I unbent it, it fractured. That's not a surprise to people who've worked with metal before, but I think before I start welding any of this up, I'm actually going to weld this. And then when I start welding this whole thing together, I'll just bend that flange, that'll probably bend with a hammer, and then weld it all down. In a minute, I'll show you guys the gauge I 3D printed so that I could get this positioned right. But for the most part, I wanted to avoid having a bunch of small pieces, welding them all up. That's why I went with the 2 big pieces, bend them into place. It's actually less pieces than the OEM. Here, I'll show you how it fits together real quick. The OEM will have a skirt basically welded around this whole side. I'm not gonna bother with that, but it will be welded inside and out, which the OEM doesn't, it's only one side, but I'm gonna weld inside and out along both flanges here. And then I'm gonna wrap this around the front. Like I said, it was originally wrapped, I had to unwrap it and it cracked. And if that fails, I do have another strip prepared to wrap right around that. I didn't get it perfectly square. You know what, actually, let me grab the gauge and then I'll show you guys exactly how it's positioned. This is my gauge. I use this to tell me exactly where the hole needs to line up, not only to help me weld this in place, but also as a check. This is actually the second back piece I made. The first one I did, I bent it so poorly that I could see it clearly didn't line up at all. But this verifies that I have the OEM width, the OEM position for that hole up top, because that's not intuitive, right? If this flange didn't bend correctly, this base piece, even that could be screwed up. So I got that hole lined up, and I get the drop set to this hole. I'll show you guys that in 1 second, and then you'll see the whole thing together. All right, here it is fitted. You can see it's pretty close there. There's a little small gap, but that's really not too big of a deal. It's pretty well lined up to the hole. This side's actually about perfect. This side is a little bit off, but that's definitely close enough. Remember, the bushing that this is gonna, or the joint that this mounts to on the differential is a rubber bushing. So it's gonna have some compliance, enough to take up that slack. What's a little bit more annoying to me, just as trying to be a perfectionist, is the angle here between this piece and the base is not exactly 90 degrees. I wanted it to be perfectly perpendicular. It's close enough. I think it'll work. When I say I think it'll work, I'm going to weld it up. I'm going to commit to this design. If I try to bolt it in and it doesn't fit, I'll try again. Actually, if this doesn't work, I'm probably going to opt to doing many small pieces with a more complicated jig so that I can get everything exactly where it needs to go. I'm trying to make a more robust system by having just 2 bent pieces, less welds, less pieces, but it is surprisingly difficult to get a bend exactly how you want. So just bending those 2 wings, this was one big flat piece, you can see I didn't get it exactly right, so now it's, maybe 95 degrees instead of 90, just enough to bug my OCD. And I don't know if I mentioned this yet, this is a 3D printed gauge, so it won't hold up to heat. All I'm going to do is spot weld this in place, and then I'm going to pull that out before it melts or catches on fire. All right, I figured I'd show you guys. I'm committing to the design before I actually fully weld it up. Just a couple spot welds on each corner. I did weld the back side of this where it was a little cracked. Oh, something else I forgot to mention. The brake I ordered was a sharp tip brake, but I rounded the tip off. I used the Tormac so that I could bend with a 1/4 inch diameter radius. It probably looks a little tighter than that, but I didn't want to bend or try to bend this 1/4 inch plate with basically a perfect crease. It was just too much flexing. I wanted it to have more of a gentle turn. Not that a 1/4 inch radius is gentle, but just enough. If I could do it over, maybe I would have gone for 1/2 inch. You can see it really is straining. I've also considered maybe filling in each of the holes with some weld. Is it necessary? No, but I don't really like the look of them. But like I said before, it was kind of necessary, both as a guide and just to help relieve the strength of the 1/4 inch plate. All right, I'm gonna weld it up. First set down on each side or the outside. Like I said, I'll go on the inside too. It's kind of funny to show this on a YouTube video. I'm sure every single guy that watches this could do a better job. I am not a welder, professional welder. Father-in-law has a nice MIG welder, taking advantage of it. I'm an engineer. I can defend myself in that right, but as far as welding goes, I probably should go a little slower. I think this bead looks a little light, but it's probably going to be fine, especially if I go on both sides. And again, this isn't like a key chassis. Whoops, not a key chassis component. It's just kind of holding the position of the differential. It's not important, but it's not going to see, you know, the crazy high loads that the suspension components would. So far, so good. All right, I went ahead and welded in the hole as I took the bead along the interface here. It kind of left a little bit of a gap on the inside and outside of both sides. So I went ahead and filled those in the rest of the way. This one was not really, sorry, a little off with my pointing. That one wasn't necessarily right on the line, but it was close enough to the weld that I wanted to fill it up so there wasn't too much of a stress concentration there. Maybe I'll fill them all up, I don't know. But this one right here was real tiny. I'll try to bend this or wrap that tab off the front and weld that up. Then we'll see how the whole thing looks. It's probably more than adequate. I can't imagine it's any worse than what you get from rough country. Well, guys, I can't say I'm too surprised. When I went to wrap this over, it refractured where it had before. This would have been perfect if I waited to bend that last, but because I bent it first, then bent it back and cracked, it's just, you can't work it that much. I'm going to try to salvage it. I'm going to cut this junk out, weld it, because I can always put this bolstering over it anyway. And again, that's not going to affect the clearance of anything. So we'll give it a go. I'll see if I can clean that up, fix it up best I can. You know, I can weld in everything, fill in the holes, get some wrap on the front of this. And if it looks like it still needs some help, I can throw that on too. Maybe that'll be a little bit of a bash, you know, a bash guard for the whole thing. I think it'll be fine. It's a little bit later now. Sorry for the low light. I got sidetracked while I was letting this cool off. Pretty happy with how it turned out. Welded up inside and out and the front. This turned out pretty good. I don't think this is going anywhere. I don't think there's any reason to add that extra bolstering on the front. That's pretty rock solid. And I've got a lot of extra material there. I don't know when I'll get around to bolting it in, but first I'm gonna, you know, prep it a little bit, prime it, paint it. Hey guys, I've got the diff drop bracket painted. You may notice I don't have the weld nut on the back. I totally forgot about that. I thought I could come up with a better explanation, but nope, I just totally forgot to get the right nut for that. So I'm still going to test fit everything today, and I've got two options. One, I just put a nut up there and hold it with a wrench, which would be fine, or I strip some of the paint off and weld the nut on there, and it'd be a whole lot easier to deal with the install and tear down in the future, just having to worry about the bolt like the OEM design. One thing I haven't shown before, I don't think, is the other two parts for this diff drop bracket. If you've seen kits before as part of suspension packages, there's often other components involved. This is for the right-hand side bushing, and this, forgive my paint here, it's not great, but at the same time, I don't care. Nobody's going to see it. I just kind of wanted a little bit of corrosion resistance. This is a spacer that will go on the differential between the main differential housing and the, for lack of a better word, the bracket that holds the bushing for the rear mount. So this is going to be kind of left-hand side where the main differential housing is, and this will be over on the right-hand side where we have the third mount. And just to show you guys what I'm talking about, here's the third mount. That's where this spacer is going to go. Obviously, the main drop bracket will be up front on the housing. And then, as you can see, there's two little bolts here to unbolt this member from the main housing. So I'm going to take those out. I have longer ones ready to go. And put in, this is a 1/2 inch chunk of steel. One side's a little bit larger to fit the, there's a alignment collar, so that'll help keep everything centered. So surface level, it seems intuitive that if you want to drop the differential, you're going to have some type of adjustment at all 3 points of contact. That's not necessarily the case. In fact, some kits don't really do, actually I think most kits don't really do anything with the back here. You just tip the differential down from the back pivot, and then they give you some spacer here and spacer there, or new bracket for the front. I am tipping the differential down so that the center line moves down 20 mils. But when you pivot down from this point, you're pulling this point and this point back. You know, if you imagine the arc that you're rotating down, these move rearward. And to get this to line up the way I want, because I don't want this thing even slightly, misaligned side to side in the vehicle, to get this point pushed back forward, I wanted to space this off of the housing. And 1/2 inch is just about what I need. The other thing to take into account is that as you rotate this down, I know that the center line drop is 20 mils based on my computer CAD, but because there's a little bit of rotation, this point did not move down 20 mils. I forget if it's 16 or 18, whatever it is, that's what this is. So there's going to be a little bit of, whoops, sorry, my screen turned off there. There's going to be a little bit of torquing in this bushing and this bushing because we're rotating it down. The front one will be at a nominal position, but of course dropped. And that's going to be dropped to more than 20 because we're achieving 20 at the middle by maintaining the same position here, moving the housing forward 1/2 inch as we rotate it down. And this, I think, works out to being 30, 35 down. I would have to check my computer CAD. If you guys want to see those details, let me know. All right, here's a little side-by-side. This one is substantially heavier than the OEM. That's primarily because I'm using thicker sheet metal. Previously, I noted that I didn't have the nut welded on here. It actually has two, one for the main mount and one for the bracket itself to the frame. These look like they might be easy enough to just cut off. They just have a couple spot welds. And I think I will do the same. Just cut them off and spot weld it on here. What I totally forgot about or didn't account for is the skid plate also mounts to this. So that's a miss on my part. I tried to simplify the design a little bit, and in doing so, I lost this flat bottom. So you can see here, see if I can prop that one up. Side by side, I have a much more gradual ramp on my design instead of that steep bump right there, because I anticipated losing a little bit of clearance with the lower bracket. So I wanted to essentially get as much of a ramp as I could in case I needed to slide off of it. But now I don't have a flat to mount the skid plate to. I did anticipate having to cut some of the skid plate out, so I might have to cut out that entire mount, which might be might take off more of the skid plate than I intended to, since there's not going to be any room to mount here, and you already have clearance at the back for the diff. I may have to take that window and just bring it all the way forward past that mount. We'll see. I'm not against having to fabricate my own skid plate anyway, but I don't really feel like trying to put a weld nut on this and coming up with some other mounting. This I want to kind of leave dedicated for the differential, and I'll find a workaround for the skid plate. Just wanted to take a moment to show you guys what it looks like back here. It's not super convenient to reach the differential, the rear bracket here. This is the bushing bracket, and then there's two bolts here. One of them is just out of view. Let me move the light here. So you got top one there, bottom one there, and those mount to the housing. Not sure I can show it. Okay, you can see it just there behind it. So the differential is dropped since I pulled those out. That's where the spacer is going to go. And as you can imagine, this may be a two-man job, since I think I'm going to need help holding the differential up. Right now it's just sitting on a jack stand, but I think I'm going to need a little more finesse to position that while I put the spacer in and then run the bolts back into it. All right, you can see the new bolts in there. I don't have the final torque check on them yet, but that was actually surprisingly easy. Just needed to use a floor jack under the differential. I do have, obviously the front mount and right side mount are off, so that it's pretty free to move the differential around and position it. But getting that little spacer on was super easy because that collet or collar to position was already in there. So that's pretty easy. Okay, so we have the back mount hooked up. Now I'm going to do this one. That's where this spacer is going to go. So instead of running this bolt through just this and cinching it down, this is going to be offset from the bracket. Let me see if I can get you a view. That bracket, normally it's going to butt right up to it. This time we're going to have a little spacer. Camera's struggling to focus. Right between those two. It should line up. And again, I'm going to use a slightly longer fastener to make up for the lack of thread engagement. All right, guys, it fits. No issue with these bottom mounts fitting into the frame. As you know, I need to fit the weld nuts here and here. Well, I say weld nuts, maybe I'll just leave them free and put a wrench on it. It's not that hard. But the drop is in. I've got all three brackets in. This is the one I was most worried about fitting. It's going to take a little bit of finessing of the skid plate to get it to fit around this. Obviously, like I pointed out before, I'm missing a mount here that I had before. But overall, for the drop in clearance, I like that really low angle. I don't think that's going to get hung up real bad on stuff. And for those wondering, this does fit with a 74 weld rack. I installed that the other day too, so I figured I'd knock them all out at once. I'm kind of bummed that I forgot about the fasteners on my own bracket, but I was worried about the clearance fitting with this rack because, I'm sorry guys, I'm trying to get a good view here. Let me swing over here. Because as you know, the 74 weld rack has a whole lot more beef than the OEM rack. But look at that, that's plenty of clearance to the diff. This is the completely assembled diff drop. This is the Lobo hidden winch skid plate. The original diff drop does protrude through the skid plate. There's a groove for it. As you'll see in the picture, I had to make this groove a little larger because this new bracket extends much more forward than before. And that was to achieve as low of an angle as I could for the amount of drop. You can see that the actual amount of drop is not too bad. I would argue that it's not any lower, I didn't measure it yet with the tape, but not any lower than the skid that's under the sway bar disconnect. Forgive my cheap rattle can spray paint job on the skid plate here, but you can see that I had to remove some material right where the diff is dipping down. There's a hole in the OEM skid plate for the differential there, but because the differential dips lower and because I lost my mounting point here, I just cut that entire side off so that this is all exposed. But honestly, I'm not too worried about that. It's a pretty tough housing, and the steering gear now is a 74 weld one, but even on the stock one, I'm not too worried about that. The electronics are under the skid, so I'm really not worried about this. And if you're worried about the CV, that was already exposed because that fold tucked up right here. But I did try to keep as much as possible, including the fold here and here, because those folds give the sheet metal a lot more rigidity. But overall, I'm pretty happy with that. And just for the sake of comparison, if you wanted to take a look at your own, sorry about my finger there. The clearance here would be the easiest indicator to see what was gained. This is probably 1.5 inches. It's pretty close before the drop. I'll show you what the other side looks like. Exactly the same. And that's a good view of the spacer there on that third attachment point. See if I can get a good side view here. Overall, I'm pretty pleased.